Now let me tell you just the points of story how we have established the reproducibility of OLED performance. For reproducible OLED performance, it is crucial to maintain an accurate deposition rate throughout the vacuum thermal evaporation. For this reason, we developed a custom-designed crucible. With the new crucible, the quartz sensor always see an averaged molecular flow, leading to almost no fluctuation in the thickness reading. As you can see in the bottom left table, we achieve very small run-to-run variation in the deposition thicknesses, which are controlled within plus minus 1%. Also, as you see in the bottom right figure, the new crucible ensures a stable deposition rate regardless of the material's filling quantity. We ensure the reproducibility of OLED lifetime by utilizing an automated VTE system. The top two figures show the run-to-run variations in the time spent for VT runs for making exactly the same OLED architecture. Also, the corresponding OLED lifetime data are indicated in the figures. Unfortunately, the conventional VT without automation is subject to a large fluctuation in the OLED lifetime because the fabrication time varies day by day. In such a situation, the credibility of the lifetime data is questionable if you want to evaluate the superiority of your product. With our full automated VT system, the fabrication time can be constantly regularized, so we see only marginal run-to-run variation in the OLED lifetime. Because of the high reproducibility of the baseline OLED performance, our customers can rely on the evaluation data. Next, I would like to introduce very unique method. You can find the full technical presentation at session 55 of the symposium, so I will show you here only a few slides for a brief introduction. Here I explain the concept. We attached a new customized chamber to the VT system. The aim is to perform intentional in situ impurity exposure to specific organic interfaces during an OLED fabrication. Let's look at the schematic image at top left and choose a typical TADF OLED architecture as an example. And you want to check whether the outgassing from some vacuum component or from some chemical species is the killer to OLED lifetime. And let's assume you are interested in whether the organic interface at both sides of the emission layer is susceptible to the influence. In this example, you are focusing on the interface between trace PCD and meta CBP, and also between meta CBP and T2T. Now you start the OLED fabrication. The deposition of hot CN and trace PCD is done. Then the OLED is immediately transferred into the exposure chamber and the organic interface is exposed to the suspicious impurity source. After the exposure for a specific time, the OLED is returned back to the organic chamber to complete the emission layer. If you want the second intentional exposure, just repeat the same procedure after the emission layer is done. Finally, the OLED is returned to the organic chamber to complete the remaining organic step. Then after the fabrication, you do analysis of the OLED lifetime by comparison with a non-exposure reference. This is a typical result of the killer identification after the analysis of OLED lifetimes. We clearly see from the figure that the impurity source 1 is indeed the killer, while the impurity source 2 has no impact at all. In addition to the study of the impurities, we can also study on the impact of water present in the vacuum chamber. For this purpose, a cryotrap is equipped to the exposure chamber, which can reduce the amount of baseline water. The advantage of controlling the water baseline is that we can distinguish the two different factors that are impacting OLED lifetimes, namely the impurities and the residual water. Okay, to summarize the OLED technology part, we have developed methods that are very useful for our customers to solve their lifetime issues by distinguishing or by combining different factors such as residual water, chamber impurity, and material impurity. These are based on our effort to always ensure our customer the reproducibility of device performance. Again, for more details, please attend our presentation in session 55 of the symposium.